times you'll have these scenarios here, okay? You ready, guys? Determine the mean and standard deviation by hand, right? There it is. Without the TI-84, you can still use your calculator, but not like the function mean and standard deviation. This method is used when we're given limited information about a data set. If only two values are given, the question will often mention the percentage of values located between them. And I have to add something, okay, because I keep on trying to improve on this one. Or the associated z-scores. Can you write that? Can you add that to your notes, please? So they'll either give you the percentage in between or the associated z-scores. Okay. Is it just me or is it blurry? If 68% of data falls between the values, we have to know that it is one or plus or minus one standard deviation. So technically, right, if you go one to the left and one to the right, there are in fact between those two values there are two gaps. So that makes sense, right? Two gaps. If the question says 95, right? Remember, this is the empirical rule right here. If it's 95, then we know that within those two values we have plus or minus two standard deviations. That would be the equivalent of four gaps, right? Because if you go from the mean always, right, two to the left and then two to the right, between these two values that we're considering along the x-axis, there'd be four gaps. And so if you go 99.7, which is often called the majority, that would be six gaps. So 2, 4, 6. That's basically how it goes. Right? So there are either, let me use my pencils here, right? They're either, if it's not 68% mentioned, then we know that between these two values, there's 1, 2 gaps, right? If it's 95, between these two values, we have 1, 2, 3, 4 to get from one to the other, right? There are 4 gaps. And last but not least, if it's 99.7, between these two values, there are 6 gaps, right? To go from one side to the other. 6 standard deviations, so to speak. So we can use the following formulas to figure this out. We take the upper value, which would be on the higher, plus the lower value divided by 2. To find the standard deviation, we would go upper value minus lower value divided by the number of gaps. But I want to change this. I've updated. I have a sticky note here. Can you just do that on the side here? To figure out the average, one second. My bad. I will do one here, one there, okay? To figure out the standard deviation, I will do this. Upper minus lower over z-score of the upper minus z-score of the lower. That's how you find the standard deviation. If you want the average, the mean, you just take the value along the x-axis minus the z-score times the standard deviation. I'm going to ask you to use these instead. So because these work every time, I'm going to ask you to do this. Isn't that satisfying? But it messes up my nice notes, right? I get it. Upper, lower. So standard deviation, average, right? Use these, they work every single time. And you might like z up, z low, what's that? If you are here, you your z-score would be 2. If you're down here, your z-score would be -2, right? So there are z-scores associated with every value. Just keep that in mind. So I think I just want to put this to practice right away, right? Use these right away. Add them to your study sheets. Here we go. A farmer fills bags of potatoes in order to ship them to a local market. After weighing all the bags, she finds that 95% of the bags weigh between 95% of the bags weigh between this and this, right? Let's keep going. Assume that the distribution is normally distributed. The weights is normally distributed, right? So we need to know that. Determine the mean weight of the bags. Well, I'll give you a little start here. We, right now, just a sketch, we're not drawing this to scale. This is my middle here. I'm going to go up, do this, okay? If it says 95% of the bags, you should know, that should tell you that we're going 1, 2, right? And then we're going up 2 as well. That's 95%. So we're going to block this in. That's 95% of the bags. So that means that this is 56.4 and this is 65.6. What's the z-score for this one here? Without doing the math. It's 2 standard deviations, right? So this has a z-score of -2. And this has a z-score of 2. Automatically, you just know it, right? Because we're actually landing exactly on a standard deviation on either side. Okay. Can I just say this? This is plus or minus 2 standard deviations, right? Everything is connected that we're doing here. So to find my standard deviation, that's the first thing I would suggest you do. Find the standard deviation. Find standard deviation first, if you can, using that formula: upper minus lower divided by z up minus z low. So upper means you actually take the value on the upper limit and you subtract the value on the lower limit, and then you divide it by, you got to be careful here, the minus comes with the formula. This is the z up, 7 up, and this is the 7 low or 7 down. Okay. So you go 2 minus -2. Oh no, double negatives. Okay. So then 65.6 minus 56.4, you get 9.2 over, this is actually plus, right? So it's 2 plus 2, that's 4. And what do we get there? Some of you are clicking, I hear you clicking away. That is my standard deviation. That is my standard deviation. Right now I don't have time, but if you were to start here and keep adding 2.3, 2.3, 2.3, 2.3, you will actually get to 65.6, which stands to reason you're almost done. We should be able to get to the average, right? If you just add 2 standard deviations, we get to the average here. So I'm going to tell you this. The average was the value, so you pick, I'm going to pick this value, 56.4. It calls for minus, what's the z score or the z score for this value here that you're using? My finger right here, right? -2. Times the standard deviation. What's the standard deviation? 2.3. this is actually exactly the formula that I was giving you. So 56.4, this is going to be double negative again, right? So that's plus, and then 2 times that is just 4.6. So the average is, where am I here? 61 kilograms. Mr. Dixon, do I have to use the formula, or could I have just gone 56.4 plus 2.3 plus 2.3? Yes, you can do that. That's absolutely fine. Okay, so I kind of mixed it up. I said I did B here, and this is A. I'm going to leave it there. I'm going to leave it right there. Have this on your study sheet, okay? You know what? I'm not gonna have this on the quiz tomorrow. If it shows up, I'll just get you to cancel it. I want to do one more example before. Okay. So for review, I give you these 3 handouts here. I will post each key individually, so you just look for the keys on Google Classroom, okay?